Hello guys, good evening everyone, and welcome back to 360DigiTMG's domain analytics program. I think it is sixth day that we are continuing the web and mobile analytics. And today we will be discussing about decision tree and how can we apply the decision tree algorithm, that is a machine learning algorithm when it comes to web and mobile analytics. The very first day that we have discussed what are the applications when it comes to machine learning in domain, that is web and mobile analytics. What are the changes that you can make? What are the advancements that you can make using the machine learning algorithm when it comes to web and mobile analytics domain that we have seen? And the next day, the second day, we have seen crisp ML methodologies, cross-industry standard process and machine learning, that we have seen what exactly it is. And irrespective of the domain, crisp ML methodology is the phases, different phases we will be applying when it comes to data science project. We have seen what are the different phases and what exactly happens when it comes to those phases. And then we have seen what are the different algorithms, various algorithms we have seen, supervised, unsupervised. What are the difference between those? How processing happens if it is unsupervised case, and what happens when it comes to supervised case that you have seen on the third day. And then we have taken unsupervised algorithm, that is k-means, and we have applied in real time. We have taken one use case scenario and we have applied the unsupervised learning, that is k-means algorithm, and we have tried to do predictions. And then we have taken the supervised learning, that is KNN algorithm, K nearest neighbor algorithm. It is one of the supervised algorithm when it comes to classification. And we have applied the use case saying that if you have some transactions, which transaction could be fraud. We've done prediction using the KNN algorithm, that is K nearest neighbor algorithm. And then now we will be having the decision tree. Now we will be having the decision tree. It is one of the most important, you can say, algorithm or machine learning model, you can say. So this is the one of the most important algorithm when it comes to decision tree. On decision tree based only, we'll be having so many algorithms like random forest, XGBoost, light boost. So those are the different algorithms we'll be having based on decision tree. So in today's session, we will see what exactly the decision tree is. We'll go through agenda, what exactly the agenda is. What is the decision tree? How to build a decision tree? And a greedy algorithm, what exactly the greedy algorithm? Where we will be using the greedy algorithm, that we will see. And build a best decision tree model. To do, to build a best decision tree model, what we are supposed to do? What are the things that you have to keep in mind? And how can we select the attribute? I mean, which is the root base? How can we select? How information gain, will have an influential role selecting the attribute, the root node. And we will be taking one use case scenario and we'll try to apply and real time and see how we can apply the machine learning algorithm. So when it comes to decision tree, it is one of the supervised algorithm. It is supervised. What is supervised that you have seen in the second day? I'm just will give you a quick review. Whenever you have a data frame, if you have an output, or label. In that case, we will be using the supervised learning. You have different inputs or features. You can say x1, x2, x3, x4. These are the input features, or you can say independent variables, and we have output, that is a dependent variable, or you can say label as well. Whenever you have data set, something like that, you can simply go with supervised. Since you have output, you can go with supervised algorithm. So decision tree is also one of the supervised algorithm. When it comes to decision tree, what are the components we'll be having? Decision tree means what are the components we'll be having, that we will see. So decision tree algorithm, nothing but it's just an if and else ladder. What happens if this condition satisfies? What happens if that condition is not satisfied? These are all kind of if and else ladder. All the decisions are making are in the form of if and else. What happens if that particular condition is? Let's say one simple example to understand how decision tree algorithm is executed. Let's say it is 8 p.m. in the evening. You need to have a dinner. First, what you will see, what are the conditions? Are you hungry or not? The very first condition, are you hungry? Yes. In that case, we'll have one condition. No. In that case, simply go and sleep. That's it. End of the loop. But if you say you are hungry, in that case, we'll go for like how much money you have in your pocket. If you have 1,000 rupees, yes or no. If you have yes, in that case, you'll be going for some fancy restaurant or simple restaurant. You going for dinner in restaurant. If you don't have, in that case, no, you don't have 1,000 rupees in your pocket. In that case, what do you do? You'll simply go with juice, some that can, if you have like 100 rupees, still you can simply go with dosa, some dosa place, and simply have the dosa, and then you will go sleep. If you have 1,000 rupees, in that case, you will go to restaurant, and then you will have fancy dinner, and then you will go to sleep. So these are what? These are different conditions, different rules. This is how decision tree will perform. First, we will check what are the conditions we will be having. Yes or no. Based on that, it will keep splitting. It will simply keep splitting. This is how decision tree. Decision tree is means conquer. Split and conquer. It will split into two cases, and then it will take a decision. These are what different rules. These are different rules. What if you have 100 rupees? But if you don't have 100 rupees, if you are not hungry, if you are hungry, these are the different conditions. These are all different rules. Decision tree is all about forming rules. Decision tree is all about forming rules. I hope you guys have an idea about what exactly the decision tree. This is a decision tree, right? Whenever it is ending, in that case, we will be calling it as leaf node. Or you can also call it as terminal node. And where exactly the splitting is started, that is called root node. Where exactly the splitting is started, in that case, we'll be calling it as root. So we'll see what are the components we'll be having in the decision tree next slide. Root node we have, and then we have decision node, and these are all leaf nodes. Root node means where exactly, which feature it is considering as a best root node. For that, we will be having process which root node to be selected. That we will see in a minute. But these are the components when it comes to decision tree. Root node will be having, decision node will be having, and then we have a leaf node. This is also called as a terminal node. Terminal node. These are the different components. In decision tree, the non-terminal nodes and the terminal nodes are different. Non-terminal and terminal. Non-terminal this and terminal nodes are this. Non-terminal nodes are used to make local decision. So using the non-terminal nodes, you will be making the decision, and local information they are based on the information we will be splitting into different. Terminal nodes make the final decision. So once the decision is made, end of the tree. Once the final decision is made, that is the end of the tree. So here you can see leaf node, that is also called as a terminal node. A path from root to leaf represents the classification root. So you will be making different rules, right? This is one root, this is one path, this is one more path, and this is one more path, this is one more path. So these are all what? Rules. Rules of the decision tree. The number of, or you can simply say the number of leaf nodes present in our decision tree, those are called as a rules. Let's say this is one decision tree, then in that case, how many rules we have? 6 rules will be having. Like that, decision tree will be formed. A path from root to the leaf represents one classification rule. Based on this only, we'll be classifying the any data into different categories. A decision tree consisting of 3 types of nodes, that is one root node, branch node, and leaf node, that we have already discussed. So this is how it looks like when you are forming the decision tree. It will simply select one root node. Based on that, it will keep splitting. It will keep splitting. It is one of the COVID cases. It is one example how decision tree will look like. Based on the number of conditions we'll be having, it will keep splitting, and this will become one root. How to build a decision tree? This is supervised learning, one of the important learning decision model that you that it is one of the models that we have discussed. So how can we build the decision tree? So in order to build the decision tree, first you have to find out which is the root node, best root node to split. So it is kind of like what you need to have a least rule. Less rules are least rules, and you have to get maximum information. You have to form very less rules and you have to get maximum information. That is the goal of our decision tree. So let's say you have one data frame of how much? 10,000 entries. For that, you have created a number of rules. What? How many number of rules? Let's say 9 rules. You have how many features? Let's say you have 5 features. 5 features means 5 input variables. Each input variable, it is called as a node. Each input x1, x2, x3, x4, and x5. And we'll be having output, obviously, since it is a supervised case. So these are all called nodes, different nodes. What we will be doing here, using the grid. Using greedy algorithm. Using greedy algorithm, we will be taking each root node. We will be giving taking each root node and we'll be checking how many rules that we can form. We'll be taking all the root, all the input features we'll be having. We'll be considering as a root node, and then we'll be forming the tree based on the different conditions we'll be having, and then we'll try to find out how many rules we are forming. How many rules we are forming? Wherever you are getting the least rules, like less number of rules. Let's say you have 5 features. Each feature you are considering as one root node, and then we are forming the tree. Here we have considered one root node, that is x1, and then we have formed. When it comes to x1, feature x1, you got 8 rules. Let's say you have 5 rules. Using x2, you got 10 rules. x3, you got 15 rules. x4, you got just 5 rules. In that case, which one will you consider for the best decision tree? Least rules, maximum information. In that case, we'll be considering x4 as the best root node. So we'll be finalizing x4 as a best root node. From that, we can start building the tree. Like that, we can form the rules. We'll be having greedy algorithm to find out which is the best node or which is the best root node. How can we do that? Root node. We'll see now. Which is the best root node? How can we find out? Using the grid algorithm. Which is the greedy algorithm. Tree constructed in top down. See, normally what happens in hierarchical clustering, you might have seen. So whatever the structure that we are making, that is called what? Dendrogram when it comes to hierarchical clustering. So what we are doing in hierarchical clustering, if you have 1000 entries at the beginning, you are considering as 1000 clusters. First, we are considering if we have n entries, we'll be considering as n clusters. And then based on their similarity, based on homogeneity, or you can say, based on the similarity, we'll simply grouping into different. We are differently grouping into different groups based on what? Similarity. So it is what? Bottom-up approach. So very simply grouping from the bottom-up approach. In interview, they might ask you, what is the bottom-up approach? Where exactly we'll be using? What is the top-down approach? Where exactly we will be using? What is the difference between both? So when it comes to decision tree, what happens? It is a top-down approach. What we are doing? Checking the conditions, and based on that, we will be splitting, right? Decision tree will be splitting from top-down. It is a top-down approach, or you can also say divide and conquer manner. Top-down recursive, or you can also say it is a divide and conquer manner. Attributes are categorical. So what happens? Since it is a decision tree, you need to have some discrete value to make a decision. So when you have continuous value, you will be having maximum unique values. Let's say 10,000 data, and if you have continuous variables, in that case, there is a possibility you have 10,000 of 10,000 are unique values only. In that case, it is not possible to do the splitting. For that, we will be converting into continuous value into discrete value. We will be converting the continuous values into discrete variable. That is also called as discretization. Or you can also say it is a binning. Since we are using the classification, that to decision tree, we need to have a categorical classes. We'll simply converting into the continuous values into categorical. Input data is partitioned recursively based on the selected attributes. Of course, we'll simply based on the attributes, we are splitting into different. Test attributes at each node are selected on the basis of heuristic or statistical measure. Example, information gain. So we'll see what exactly information gain in a minute. Condition for stopping the partition. What is the condition? Like we will be building a tree. continuously, rigorously we are building. So what is the, when exactly we have to stop? When exactly we have, all samples for the given node belong to the same class. When you are building, so we'll be having condition. All the samples belong to the same. Let's say if you have S and no cases, you are doing the classification based on whether you have a COVID or not. This is the case, you can say use case scenario. You have a COVID or not. Just two output you will be having. You need to have a same homogeneity in one side. You should be having all S's or all no's. Homogeneity, maximum homogeneity. Maximum means you have to have all the same similar category or similar classes. In that case, you can stop. That is one condition. There are no remaining attributes for further partitioning. You don't have any other. You don't have any information to further split. In that case, also you can simply stop it. There are no samples left, and if you don't have any samples left, in that case also you can simply stop the decision tree. From that, it won't extend or it won't form any decision trees, any node it won't form. So that is what terminal node, the final, or you can also call as a leaf node. So these are conditions where exactly the decision tree should be stopped. It should not be having all samples are given node belong to this. It should be homogeneous. Homogeneous. All the categories should be yes or it should be no. In that case, it will simply convert into no. It should be converted into yes. And shouldn't be having any attributes further partitioning, or you can say there is no sample left more. Yeah, that is one thing here. These are the conditions for stopping. So we have a information gain to find out which root node is the best root node. For that, we'll be having we'll be having one process to follow. We'll see that now. Entropy. So here entropy means measure of impurity. Impurity means if you have a classes yes or no. Let's say if you have 50-50 classes, total how many we have? 10 we have data sets or data entries, you can say. In that 10 we have 50 COVID, about COVID only, yes or no. 50% means in 10 data frames we will be having 5 yes cases and 5 no cases. Here you won't be able to make any decision. There is no probability that you can make a decision. If you make decision, it will be 50-50 case. So it is the worst case. In that case, we'll be having maximum impurity. Maximum impurity means you won't be able to make any decisions on that particular branch, you can say. Maximum impurity when you have 50-50 cases. In that case, let's take one example. Tossing a coin. So you have just 2, whether it is head or tail. In that case, what is the outcomes probability? 50-50%. You can't tell. You won't be able to make a decision. So it is called maximum impurity. Will be whenever you are not able to make decision. In that case, we'll be calling it as 50-50% or maximum impurity. And here entropy will be 1. This is a measure of impurity. You won't be able to make a decision. If output is 0, set is pure, entropy is 0. So if you don't have anything, all the homogeneity case, in that case, there is no impurity, 0 impurity. If all our cases homogeneous, you can simply make a decision. Entropy is 0. If the output value is split in between 25-75. In 10, 25. Let's say 100 cases, 100 data frames will be having in that. 25 yes cases, 75 no cases. In that case, you can tilt a bit towards no cases. Probability will be higher. So here you can say what is the entropy? It is a 0.811. 80% impurity, you can say. So how can we calculate the information gain and how it is useful to find out which root node is the best? The information gain is based on the decrease in entropy after the data set is split on attribute. So what we will be doing, let's say you have a data frame x1, x2, x3, x4. This is the data frame we'll be having, and it is out. First, we'll be finding out entropy of the whole data set. Entropy before splitting. Maybe entropy before splitting minus entropy after splitting. It is information gain. IG. It is an information gain. Before entropy before splitting minus entropy after splitting. Using this, we'll be calculating the information gain. But like that, we'll be calculating information for all the features. Like that, we'll be calculating the information gain for all the features wherever you are getting the maximum information gain. Wherever you are getting the maximum information gain, that node we will be considering as the best root. That node we will be considering as a best root. You can see here, entropy, expected information needed to be classified. Here we can this is the formula for calculating the PI, number of classes will be having, whether it is S classes or no classes, and then the same class. So if we have S classes and no classes, if we have just two, in that case, this formula could be written as PI, in case of P, S you can say log 2, PS cases plus P no cases log 2 of P no. Probability, that is what PI means, probability of S and probability of no. This is the information gain for what? The first data frame before splitting. Once it is started splitting, in that case, information gain, it is what? When you are doing the splitting, in that case, how many classes you have? It is the total classes. How many classes you have into total classes? Same information gain. The same information gain will be applied. Here, gain. What is the information gain here? Entropy before splitting, entropy after splitting. It will become the information gain. So here, whichever information gain, highest information that you are getting, we will be having different features, right? Each feature will be considering as a node. Then we will be doing the information gain. We will be calculating the information gain. Wherever you are getting the maximum information gain, that we will be considering as a best root node. Best root node. Now we'll start splitting from the root node. Why it is best root node? Since using the least rules, we are getting the maximum information. That is why it is called as the best root. So when it comes to decision tree, we have one drawback. Let's say it is bound to underfit. Sorry, it is bound to overfit. Why it is that? So whenever we are doing the point-to-point classification, it is going through each and every point. In that case, there is a possibility, not just a possibility, it will simply remember whole data. It remembers whole data frame. It remembers all the data, and whenever you are applying the training accuracy, whenever you're doing the model, it will simply copy paste it. So whenever you're doing the training accuracy, in that case, what happens? It will give you 100% training accuracy every time. What it will do? It will simply give you 100% accuracy on trained data. And if it is giving the same for test data, no. And it is not performing well on the test data. It will be for training data, it will be giving you 100% accuracy, and it is not performing good when it comes to test data. This is called overfitting case. When training accuracy, you can say, is high and testing accuracy is low. In that case, we will be calling it as overfitting case, or also called as variance. When training accuracy is maximum and testing accuracy is low, in that case, we'll be calling it as overfitting, or you can also call it as a variance. To avoid that, we'll be having two regularization techniques. To avoid that, we'll be having a regularization technique that one, pre-pruning, and to have post-pruning. Whenever you have a cases like overfitting cases, to avoid that, we'll be having two regularization technique. Simply that those are pre-pruning and post-pruning. So normally we will be using post-pruning. So once the whole decision tree is formed, we'll be simply eliminating whichever the not necessary, which information is not important. Those information will be simply eliminated. Additional will simply kind of cutting the tree, which are not useful information. Still we'll be having the tree. In that case, we'll simply prune the tree. There is the decision tree. We'll see one use case scenario, and we'll try to find out how can we apply the decision tree algorithm when it comes to real time. Here we'll be having one use case scenario. Based on that, in web and mobile domain only. So we'll see what is the use case scenario. Yeah, here I have a use case scenario. In that, I'll be using decision tree algorithm and see how it is performing. Let's say we have a different mobiles. Here I'm categorizing the different mobile categories based on their prices. Based on those prices, I have categorized into some categories like 0, 1, 2, 3, something like that. 3 to 4 categories I'm simply categorizing. So based on the features, we have to tell which mobile belongs to which category. It is kind of, you can say, whether it is in mid-range, or it is flagship, or it is in a lower range, something like that. Different categories will be having. We have to predict which category it belongs to based on the features. Here we have, what are the features we'll be having here? When it comes to introduction, when it comes to description, battery, of course, you might be having an idea how much is the battery of your phone. It will definitely define which category it should belong to, whether it has a Bluetooth or not. Clock speed, it is also important, so that how speed your mobile is responding, has dual SIM or not. It is also one of the important features. Camera megapixel, of course, how much megapixel that particular device has. Based on that also, price ranges. Price range depends. Does that particular mobile has a 4G or not? Internal memory, how much internal memory will be having, how many GBs of internal memory having. These are the different features. Mobile depth in centimeters, weight of the mobile phone, number of core processors, that is also important feature of particular mobiles. So these are the different mobiles will be having. RAM, how much is the RAM? It is deciding factor when it comes to price of that mobile. Pixel resolution height, resolution width, memory, random access, that is a RAM. Screen height of the mobile in centimeters, it is also important factor to decide the price of that particular mobile. And then we have screen width of the mobile, whether it has 3G or not. Talk time, battery charge, how long it will be lasting if I continuously talk on mobile. Has touch screen or not, has Wi-Fi or not. These are the different features we'll be having for mobiles. Based on these features, I have to tell which category that particular mobile belongs to. Data wrangling, I'm just importing the libraries which are the important. So here I'm importing the data from the, I have taken this data from Kaggle. If you are interested, you can simply type mobile classification and you will be finding the data frame. And if you want to work on it, you can simply work on it. And here we have import NumPy. These are the different libraries that are necessary for the model building. So one of those is NumPy. All the mathematical operation that you would like to do, that we can do using the NumPy. And then we have a pandas. So whatever the manipulation that I'll be doing, it is all present in our pandas only. Using the pandas only, importing the data frame, or some changes in our data frame, all will be possible using the pandas library only. And when it comes to matplotlib as PLT, so the visualization that I am doing, for that this matplotlib library is crucial, and we will be having Seaborn as SNS, and it is one of the algorithm that is useful for advanced visualization. We'll be seeing what are those advanced visualization, and then I'm importing the standard scalars if necessary, and then we are going for the grid search series, since I don't want to do some manual calculation when it comes to hyperparameter tuning. I'm simply using the grid search series, and so that I can bring out which are the best feature. And I'm not here I'm not using just decision tree. That is why I've imported different, but we'll specifically see the decision tree only. For that, in order to apply the decision tree algorithm, what you have to do? You have to import from sklearn tree algorithm. From sklearn tree algorithm, import decision tree classifier. Importing decision tree classifier. That we are doing. And then we have different. These are all tree-based tree-based algorithm only. Here we have random forest. It is a tree-based algorithm only. And we have a XGBoost classifier. It is also tree-based algorithm. Light boost. It is also tree-based algorithm. Here I have a metrics classification report accuracy score to for that. I need to have a metric so that I can say I can bring out what are the accuracy. What is the accuracy using, since it is a classification case, we'll be using the confusion matrix. So how many classifications I have done, how many misclassifications I have done, all those things we'll be finding out. So I'm loading the data. This is my data. Dual SIM. So here most of the cases are yes or no only, whether we have dual SIM or not. These are the different descriptions that you want. If you want, you can simply go with. These are the price ranges I will be having. 1 pixel width, RAM, talk time, how many cores I'll be having. These are the different features I'll be having. Based on that, I am doing the prediction. These are the price range in which price range that belongs to. These are the different classes we'll be having. We'll be doing the prediction using these input features, which price range is that particular mobile belong to. So here I'll be having 2000 entry data set, or you can say entries as well. And here I have 21 features to the data set, and I'll be having 21 features. And you want to check describe function in order to avoid if you have any variance in our data input data. If you have a large scale, so that we can simply apply the normalization. So here you can see minimum and maximum. Minimum, how much you have? 501. In that here we have 1998. Minimum 0, maximum 1. Minimum 0.5, maximum. So here we have a variance. In that case, what you have to do? You have to do normalization. Will be performing. Since it is a decision tree classifier, it doesn't matter whether you are doing normalization or not, because decision tree classifier will take care of that. But still, you can do it. I mean, nothing to lose, so why not? And test data set, we are simply splitting into train and test. In the test data set, we will be having the same features. 1000 data set entries I have. For training, I have taken 2000, and testing I have taken 1000. So description for this. These are the information when it comes to train data set, and we will be having test set. How many null values we have? We have 0 null values. And these are the different features we'll be having in both. You can simply go with continuous data type, or other continuous data type we'll be having, and categorical feature we'll be having. Now we'll be doing the cleaning. If we have any duplicates in our data, what we have to do? Simply remove it, since we don't have any imputation for that. See, duplication data means you are using the same data again. You are using the similar data again, then it is not required. So you can simply drop those data. And then I'm doing the exploratory data analysis once the pre-processing is done, how correlated they are. So I'm simply checking whether we have any good correlation in between input columns. So these are the different correlations. So I haven't found anything disturbing. So I'm simply going with that as it is. So maximum we have 0.5, 0.6. That is in between FC, and we have what? PC. It is for test. I mean, pretty much same you will be having when it comes to test. So these are the correlation, and then we have gone for histogram. Whether whatever the data frame that we have, how it is looking like, whether it is normal or not. See, most of the data frame will be having non-normal data. So if you want to do it when it comes to numerical, you can do it, and you can improve the model accuracy, but I'm taking as it is. So these are the data visualization, different data visualization will be having, so that we can find out the inferences. You can say dual sim pipe chart. Most of the people are using the dual sims. Dual sim yes, and dual sim no. 4GB, 4G. What are the mobiles or the feature that we'll be having with 4GB, 4G, and without 4G? 3G, how many mobiles will be having with 3G, without 3G? Touch screen, whether we have a touch screen or not. Wi-Fi, whether we have a Wi-Fi or not. Dual SIM, 3G. These are the different visualization, whether you have touch screen or not, something like that. So these are the different data, exploratory data analysis, you can say. Yeah. So now we are taking which are the important features for our model, that I am taking those features only. And then these are the continuous data. I have to check whether we have any outliers or not. Seems like we don't have any. Here we have. When it comes to decision tree, that outlier part also will be taken care of decision tree. But if you want to, you can do the outlier treatment as well. So these are the different features, and whether those are normal or not. What is the price range, and do we have any outlier or not, that we are checking. Top time distribution, and we have S3 distribution. These are the different distribution, and we are checking whether we have any outliers or not. Once it is done, now we are importing the. We have already imported the decision tree model, and I'm simply applying the algorithm. So these are the features that are not required, unwanted features from the data set. So what I'm doing, simply dropping those. Other than that, we are simply splitting it. So in order to split the data frame, what we have to do? We have to import from sklearn model selection, import train test split. Train test split. And here, how much I have given? 33. 33% for test data, and the rest is for train data. I'm applying different algorithm, not just one. I'm applying the different classification, whatever the classification algorithm will be having, I'm simply applying. Or you can simply apply the decision tree algorithm, since decision tree algorithm is not giving that much good results. So I've gone for the other algorithms also as well, since linear regression, logistic regression it is, and SVM and MLP are giving the best results. So I'm applying the other classification algorithm also. So you can simply apply decision tree, and you can check it how much accuracy is given. Here, how much accuracy decision tree is giving? 0.85. So this is how you are supposed to apply the decision tree algorithm, and that will be having. So whatever the model that we have built, it is very basic, or you can say base model. It is very base model. If you want to, you can simply apply different logistic hyperparameter tunings, and you can improve the decision tree model. Since it is not giving the best results, so I have gone with different models that we'll be having when it comes to classification. I've gone with those data. If you want, you can simply take only decision tree, and you can apply different hyperparameter tunings. Will be having maximum depth, minimum sample leaves, minimum sample split you want. These are the different hyperparameter tunings will be having. You can apply using the random grid search CV or randomized CV, and you can try to bring out whichever the features are giving the best results. I've tried that too, but it is not giving the best results, so I've gone with other. So this is the decision tree algorithm, and how can we apply the decision tree algorithm when it comes to some use case scenario. Here, what is the objective, guys? We are simply we have to find out. You can see here when it comes to the confusion matrix will be having something like that. Since I have taken logistic regression, for that you can simply see this is a confusion matrix. When you have a multi-class classification, how many we have here? 0, 1, 2, 3. These are 4 classes we have. Here we have 4 classes. When you have a multi-class classification, in that case, confusion matrix will look like this. These are all true cases and are all misclassified cases. These are classified cases and these are misclassified cases. Here I'll be taking up, since it is a multi-class classification, we'll be relying on F1 score. Based on F1 score only, we'll be deciding whether whatever the model that we have built, is it giving good results or not. Since we are getting good results, 98, 96, so average score will be how much accuracy we have? 0.96. So you can say it is a good model. Like that, you can build a model. So this is all about decision tree. What we have done? What you have done? Simply, first you have to select which root node is the best root node. Why? Because in order to get least rules, when you have a least rules, less processing time, whatever the algorithm that you are playing will give you the results. Speed is high, so that we have to go with least rules. We have to have a least rules and maximum information gain. That is why we'll be going for best root node. And then once the root node, you can check with the rules as well, or you can simply go with the information gain. You can calculate the entropy before splitting, and you can calculate the entropy after splitting, and you can simply take a difference wherever you are getting the maximum information gain. That feature you can simply take as a best root node, and from then you can start splitting the model. You can start splitting and you can make a decision tree from that particular root node. So this is all about decision tree algorithm, guys, and you can simply apply the data to that particular, and you can fit into the decision tree model, and you can predict the outputs. So this is how you can apply the decision tree model in use case. This is one of the use case scenario. If you want, you can simply take this data frame from the Google, and you can try to improve the model. So that is all for today, guys. I hope guys you have learned something when it comes to decision tree, and try to apply the same decision tree algorithm with different model, or you can simply take the other use case scenario and try to apply it. And if you want to see more of these videos, or you can simply like and subscribe the 360DG YouTube channel. And yeah, and if you want to kickstart your data science career, in that case, we'll be having Tame Python. Tame Python. The sessions are going on. The Python, especially for people who want to begin their data science career. It is very important to learn Python. So we'll be having Tame Python session name called a Tame Python by Barney sir. Barney. You can simply type Tame Python with by Barney. You can simply get in YouTube channel. And if you want to start learning, you can learn. And in next class we'll be taking one linear regression algorithm. And we'll try to use one use case scenario. We'll try to take one use case scenario, and we'll apply how exactly we can apply, or we can use linear regression when it comes to web and mobile analytics in the next session. And yeah, that's it for today, guys. I hope you learned something, and we'll see you in the next class. And yeah, have a nice day.